Hey everyone, this is Vikas. Welcome to my YouTube channel. Today we'll talk about the confusion matrix part 2. Okay, so basically here we will discuss about the confusion matrix and the classification matrix, because the classification matrix are derived from the confusion matrix itself. And if you have not gone through the very first video about the confusion matrix, I would recommend you to go through that. That would make you master uh, how to understand the confusion matrix and how to create a confusion matrix. Before starting, I would recommend you that if you wanted to grow in your professional career by learning artificial intelligence, data science, machine learning, deep learning, natural language processing, generative AIs, and if you want to grow in your career, then please do book a call, which is one-on-one call with me. I would guide you in that. Well, now we'll start. So in this confusion matrix, you can see in the column wise we have, and by the way, this is a classification problem. So in classification also, this is a binary classification problem. Okay, so you can see that in pass there are two categories, pass and fail. So in actual, we have pass, we consider as a positive, and fail as a negative. Okay, similarly, in column wise, it represents the predicted values. So the very first column, which looks like this, so this would be considered as a pass, which is a positive, and fail as a negative. All right, now based on that itself, if you'll see that if both the coordinates are positive, it considered as a true positive. If both the coordinates are negative, because in the row wise, which is actual values, so if you'll see that this is true negative, and in the predicted segment fail also, like both happens, both coordinates happen as a fail as a negative, so it considered as a true negative. So true positive and true negative is here. If we'll talk about the second one, which is called as a falsely predicted as a negative, Fn, because actual this value are positive but predicted as a negative, so that's the reason F means false, and this last value or the last word comes from the predicted, so this is negative, that's the reason it shows negative. If you come across the third one, which is falsely predicted as a positive, so false means fail. uh, Actually this coordinates say, means actually it is a false but predicted as a positive, so false and predicted as a positive, so it is represented as a FP, or falsely predicted as a positive. In the very first glance you won't be able to understand, so I recommend you to go through the previous videos and go through this video also, and at least watch 4 to 5 times, then your doubt would be cleared. As the name suggests, this is a confusion matrix. Okay, it creates lots of confusions to experienced data scientist, machine learning engineer, as well as a statistician. But if you go through this, you will come across. Okay, all right. Now there are a couple of metrics are there. I'm damn sure you have heard it about the accuracy, recall, specificity, precision, and F1 score. Okay, so basically how to calculate the accuracy? Accuracy would be calculated by considering the true positive and true negative on the top as a numerator. So true positive plus true negative divided by total. Total means we have to consider the whole values, like true positive plus false positive plus true negative plus false negative. I mean all the values we have to put into the denominator. Then only you can find the accuracy, how my model accurate. Okay, how my model is accurate, that would be calculated based on this, like true positive, then true negative, divide by the whole values, like true positive plus false positive, then true false negative, and true negative. So this is how you can calculate the accuracy. Once we talk about the recall, so recall is also called as a sensitivity. So how to find the recall or sensitivity? So first of all, we have to consider the true positive as a numerator, divide by true positive plus false negative. So now you can consider this whole, I mean row, true positive and false negative. Actually this is a actual positive values. Okay, true positive and false negative. So recall is considered as a true positive divided by true positive plus false negative. And this true positive plus false negative is also considered as a actual positive values, total actual positive values. Once we talk about the specificity, which is heard very less time, but it's also an important matrix. So how to find the specificity? So specificity is find as a true negative divided by true negative plus false positive. Because if you consider this whole row, I mean true negative and false positive, this two value considered as total actual negative. Now here also I have mentioned, uh, because this complete row would be used to calculate the recall or sensitivity or true positive rate, which actually minimize the false negative rate, because this is my negative values, right? This fn is nothing but my negative values, so we have to minimize the false negative. Similarly, for the specificity, this complete row is considered. Okay, this complete row is considered, and you see this, it shows specificity, true negative rate, or minimize the, which one is the false segment here? So the false segment is nothing but the false positive, right? So we have to minimize the false positive rate. So this is how you can find the specificity and sensitivity, or sensitivity is also called as a recall. Now we'll talk about the precision. So precision is calculated as a true positive divided by true positive plus false positive. Means this true positive and false positive together as, considered as a total predicted positive. Okay, total predicted positive. You can see this here. And F1 score. So earlier only this metrics were used. So later on this F1 score was found, because F1 score was talking about, you know uh, which would give the balanced view. Because sometimes if true positive value would be much more than in terms of true negative, or true negative value is much more in terms of true positive, and this true value would be also less, so my accuracy will not give the exact figure or exact efficiency of my classification model. So in that case, F1 score plays a role, and it gives you the balanced approach, because it considers precision and recall values. Okay, so precision, you can see here, this we have we can calculate TP divided by TP plus FP, and the recall we can find it out like TP divided by TP plus FN. Okay, so F1 score would calculated from the geometric mean of recall and precision. So 2PR, 2 into P into R divided by P plus R, where P represents for precision and R represents for recall. So this is how we can calculate. Thank you so much for watching this. If you really like this video, please do support us. Alright, so if you really like this video, please like this, and subscribe our channel. And if you really wanted to support us, then please press on the bell icon and watch other series. Thank you so much.